Hi, my name is Cody Emrick. I'm 22. I'm a computer science and electrical engineering major at Orange Coast College, and I'm hopefully going to be mentoring here soon, shadowing right now. So the goal for this project was to use the ultrasonic sensor to get the range of an object in front of it. And I also have it set up so that you can use a push button to activate it, and there's an LED that will tell you when it's actually running. So basically, here's the actual program itself. You can see I import all the pins right here, and I set up the inputs and outputs. There's the echo and the trig. What those do are, one sends a pulse of audio out, and then the other one detects it, and you can use the time between when it goes out and when it comes back in to figure out how far an object is away from it. So I also have this flash function, just flashes the LED, and then this function here, sonic, is what actually operates it. So you send it a quick pulse to wake it up, and then you start a pulse. You get the time of the pulse that it was sent, and then you see when it comes back, and you get that time, and then you can find out the difference between the time to see how long it took. You do some quick math based on the speed of sound through air to figure out exactly how far the actual distance is based on the speed it was traveling. That's a basic speed distance formula, right? And then it will print out the distance. So let's go ahead and test it right here, and it should, there we go. So it detects a press, outputs that, and then it tells you the distance, which is 4.35 centimeters, which I believe is the distance between the board and the Raspberry Pi. So some of the issues I had while building it are, when designing it, I had to build two separate circuits, one for the button and the LED, and the other for the actual ultrasonic sensor. And if those cross over at any point, that causes problems. So they need to be specifically set up to cross over only at very particular points. So for the most part, they only really interact in regards to the Raspberry Pi. As far as rethinking it and anything I'd like to improve on, I would like more crossover between them to maybe give more feedback to the user as far as what the sonic sensor is doing without needing to use a whole command line, just pure hardware. But other than that, it pretty much functions as intended. So,
Any questions?
Yeah, any questions?
I have a question.
Yeah.
Can you go more in depth on that equation you talk about for the ultrasonic sensor, on how it's able to calculate
Right.
how far an object is?
So the speed of an object is the distance it travels divided by the time, correct? Right? You're familiar with that formula? So basically you can use that, and if you know what the speed of sound is, which is like 343 meters or something per second in air, you can use that, you can plug that in to figure out how fast the sonic pulse is going to be traveling, and then you just have to calculate. So if you know it got sent out a second ago, you know it had to have traveled 343 meters in that second, right? You cut that in half because it has to, when it travels, it's also traveling back. So the object is half that distance away that you actually get. And then you just output that. Yes?
Can you also point out the direction using velocity?
Define like direction. What direction of the?
Like how is it when you're calculating the distance of two objects? Is object A to the right or to the left, or?
Well, it's all in front of. There's a sensor here. This bit, these two like speakers.
Okay.
So it's just all where it's from here. This is where it's calculating from. So it only goes in one direction. I could do other directions with other sensors, but.
Oh, so you can only measure this if it's just.
Yeah, it goes in one direction, wherever that's facing. Any other questions? Yes.
Where'd you get the 17150?
That's derived from calculating the speed of sound. It's actually twice that you have it, because, like I said, you have to have the distance because the total travel time is twice as long as the actual distance is.
I see.
So when you have it, you get that. So if you multiply the duration by that number, you get the actual distance.
Okay.
So speed of sound is a constant. That
Yes.
You're using that as a constant.
It's not a constant, but you can round it as one.
Okay.
Different materials affect sound differently,
Yes,
but through
water.
Right, water, any material really can carry sound. It's just vibrations, but through air, that's what it travels at.
Okay.
Do any of the students have questions? Any of the Codologie students have questions? Can you
Really?
each ask a question, please? It can be anything.
Anything. It's fine.
Is there anything you didn't
How-
understand, or, yeah?
How did you come up with the idea of doing that?
Well, I mean, it's just the simple concept of if you send out a signal, right? You can use that to determine certain things, and it's kind of cool to just be able to like figure out how far something is from something else just by how long it takes sound to travel between them.
I like that question.
Did you have a question? You do?
How much days does it take?
How much what?
How much days does it take?
Days.
Days?
How long did it take you to do this?
How long? It took me about from I already had the push button and the LED set up. That took like half an hour to get it all wired correctly and debug it. The adding the ultrasonic sensor took a little longer. It took about an hour and a half to add that on, and then make sure that that was all working correctly. So in total, maybe 2.5 hours.
Thank you.
Thank you.
Alright.